my name is Weston Rechtenwald. I'm a fourth year mechanical engineer here, and I'll be taking you through CAD workshop number 3 today. We'll be making this hinge assembly here, and it's joined together in this assembly file so that we can look at the motion of these two hinge bodies together. And there's also this pin here in the middle connecting these two hinge pieces. So we'll be going through this today. To start off, I want to explain how this file is set up. So we have our main file called Workshop 3. We can activate that component by just going over and hovering over it and clicking on this little Activate Component button. So now we can see the full component timeline on the bottom of the screen, and that's going to show us how the entire assembly was constructed. Then we have this component called a hinge assembly that houses all of these bodies. And so under this hinge assembly, we've created an individual component for each rigid body. So it's going to be really important when you're making CAD designs to have a component generally for each rigid body. So we can see this hinge component here. It's all one solid piece of metal, and then hinge 2 is another solid piece of metal, and we need to be able to move those components relative to one another. So we have them broken into two separate components so that we can define a motion dependency between these two components. And also important to note is that if we hover over one of these components and activate the component, we can see that the individual timeline for that component shows up on the bottom of the screen. We can go through that timeline to see how it was built. If it was working here, maybe this one will be better, but we can go through the timeline individually and see the structure of how it was built. And so if we go back into this main assembly and we roll the timeline forwards, this is the finished part that we'll be looking for. Go ahead and go all the way forwards. So to start off, we'll open up a new file, and we're just going to draw like a top-down cross-section view of one of the hinges. So just going back to this file real quick, we take a look at the top-down cross-section view. It's going to be kind of this rectangular portion and then like a little circular portion where that pin is going to go through and connect the hinges. So actually, before we start this sketch, I'm going to go ahead and delete this sketch. We're going to want to define all of our components like I was talking about. So we'll make a new component here, and it's going to be called Hinge Assembly. Now after we made that component, you can see it's activated, and we're going to make each of the rigid body components that we're going to need for this assembly inside of this hinge assembly component. So this component will be called Hinge 1, and then we're also going to need a Hinge 2. So if I go back up into the hinge assembly component, make another little component called Hinge 2. Now, as I showed you in the other file, we also need some bolts and a pin, so we're going to actually go ahead and just make those now. New component, pin, it's going to connect the hinges, as well as bolts. So we'll make a component for these bolts. So now that you kind of have the hang of making components and activating components, let's go into the Hinge 1 component that we'll be working in first to make this first rigid body of this panel hinge. So we're going to create a sketch to define this top-down view cross-section. So we'll select this top plane, and we're going to define our sketch relative to the origin. That's typically good practice. Sorry, my computer has malware that I need to uninstall. So we need this hole that is where the pin is going to go through, and then you saw there's kind of a rectangular shape going off to the right of this cross section. Now you can see there's no constraints here right now other than fixing it to the origin, so I can pull these lines around. And this rectangular cross section, we're going to want to make these lines perpendicular to one another. And we're also going to want to make one of these lines horizontal, just like that, using the constraints bar up top. So now you can see we've got horizontal and perpendicular lines in this vertical line here on the right. So now what we want to do is make a little 3-point arc. So under Create, Arc, 3-point arc. we can join an arc right here. So those are the first 2 points, and then we're just going to choose the third point somewhere out in space to define how this is going to look. So I kind of pull this arc around to get it in a reasonable place, and you can see the center point of this arc and the center point of this circle for the pinhole are not the same point. So we want to make those 2 points coincident so that they have the same center. So we select the coincident constraint and then the center of this 3-point arc and the center of this circle, which is the origin. And so now you can see that they have the same center. So now what we're going to do is add a couple more constraints before we start dimensioning. That's generally going to be the best practice, is to constrain your sketch as much as you can before you start dimensioning. So we want to make this circle here, this outside circle, tangent with this upper boundary line here, so that this 3-point arc is just going to be straight tangent with this horizontal line here. And then also what we're going to want to do is make this line here tangent with the top of this circle, so that this line is just going to be perfectly in line with the top of this circle here. It's going to give us a good solid geometry. And now what we're going to do is add some dimensions. So I want this circle here to be some dimension. Now, how do I know what dimension to make that circle? Well, if we look into the pin that we're going to be using here today, I'd recommend you just go to McMaster-Carr. That's where we buy a lot of our components from, we get a lot of our CAD files from, and just look up this part number right here and kind of follow along with what I'm looking at in these parts. So this is just a simple dowel pin, and we can see the dimensioned CAD picture here, the drawing for this pin. We can see that it's 3.5 inches tall, and it's going to be a 1/4 inch thick, 1/4 inch outer diameter. And so now that we know that that pin is a 1/4 inch outer diameter, we're going to make this center hole where the pin is going to go through about a 1/4 inch. Now we're going to want a little bit of clearance, so if we just made it exactly a 1/4 inch plus, maybe 0.002, so 2 thou, just so that it's a little bit bigger, say 0.05, just so it's a little bit bigger, so we have a slide fit and not an interference fit for this pin, because it obviously needs to rotate and not be like pressed in. And so now we're also going to dimension this thickness here for the basically the sheet metal thickness of this hinge, and reasonable thickness is going to be about like a 1/16 of an inch. So you can see now that our sketch is almost fully constrained. We've constrained everything here on the left. The only thing that's still blue here is this line, which means that we can still drag it out horizontally. So we're going to want to constrain that. I'm just using the D key to shortcut to dimension. You can also get dimension from up here in the create ribbon here. So back in dimension, I'm going to dimension from this line over to this center point of the circle, again making it something reasonable, say about 2 inches. So now I'm going to hit finish sketch now that I've dimensioned and constrained everything. So I've got this sketch here in the hinge 1 component, and I want to be able to extrude this sketch upwards and make it into a body. So as you saw from this drawing here, we need the hinge to be 3.5 inches long because that's how long the dowel pin is. So if we just go in and type 3.5 inches, that's going to make a 3.5 inch tall hinge. Now another way to do this is going to be a little bit more robust, is if you click on the modify ribbon and go under change parameters, we can actually set parameters in this hinge 1 component that we can use to drive dimensions. So if we make a new parameter, I think we actually have to click here on this little plus sign beside user parameters that I'll be defining. We'll just call it hinge height. Actually, let's call it pin height. We'll be using inches, and we know that the pin is going to be 3.5 inches tall. So we'll hit OK. Now we have this pin height parameter. So if we ever were to change the height of the pin, we simply go in here and say, oh, now we use a 4-inch pin, or however long the pin is. Right now it's 3.5. So hit OK. And now, instead of using that hard-coded 3.5 that we have right here, we can just type P, which will show the pin height parameter here. We'll just click on pin height and hit OK. And now we have a robust way to change the height. So once again, if we went into change parameters and we just made it 4, then automatically this is going to become 4 inches long instead of 3.5. And you kind of see that robustness come into play here a little bit later. So back to 3.5. Okay, so now we have a 3.5 inch tall hinge. So now we need to make some cuts in this hinge. So you can see this hinge here, if I go and isolate it, it's not just a solid cylinder here on the left, it's got some cuts to fit into the other hinge. So we're going to need to take out a little bit of material here. So the easiest way to do that is we're going to start a sketch. So create sketch button. We're going to come around to the back and we're going to create a sketch just right on this flat plane right here. So we need to make cuts out of this cylinder, of course. And so what I want to do is kind of project in this geometry to have a reference to start forming this sketch on. So I just hit P on the keyboard. That's going to bring up my project panel. If you don't have that shortcut under create, you can see a project include, and you can see project right here. So that's going to allow us to pull in this geometry from the previous body that we've created. So I'm going to want this section right here, and I'm going to hit OK. That's going to show us from this view right here the farthest out point of this circle here and the farthest out point of this circle here on the right side also. So I'm going to actually want to do that down here, hit project again. I'm going to want to pull this circle in right here. Generally, it's good practice to not project more geometry than you absolutely need, because if you were to delete some geometry and you'd projected it in farther sketches, might cause an error. So I generally like to project the least amount of lines as possible. So I'm going to click on this line here, and we're going to start defining some sketches for cutting away this material. So basically I want to draw a little rectangle to start where we're going to start cutting away materials. So it's just kind of a rough outline here. We've got a line perpendicular to this projected line coming down. This line here is going to be perpendicular to this black line, and we're going to want to finish it up by making these two lines perpendicular. So this is going to be one of the little cutout portions of our hinge. And so we need to make this some length. So we're going to define some length here. And what we're going to want to do, since there's going to be 4 different cutout sections, 2 cutout sections and then 2 solid sections, and then the same for the other hinge, so they can mate together, we're going to want to take this pin height that we have, and we're going to want to divide it by 4. And you'll see why in just a second. So we have this 0.875 dimension here, just based off of the pin height. So that would change, of course, if we change the pin height. It would change automatically. So we want to make another little section to cut out. And so I'm just going to come down, create a line from this corner point of this rectangle down to this corner projected point, do the same on this other side. Now, I want to make these lines construction lines. That basically just means that I can reference things off of them, but I can't make like extruded bodies from them or cuts from them. So it basically keeps things a little bit cleaner because they don't really get in the way, but I can still reference things off of them. So if I just right click on that line, get the normal construction option, hit construction here. For this line on the left is hit X, that's the normal construction shortcut, makes it a construction line. So actually, I think I want to do this a little bit differently. You get rid of that line, make another line from the bottom all the way to the top, and make it a construction line. So the reason I did that, so that I can have this midpoint of the line right in the middle of the hinge. And so you can see this little triangle popping up showing me that I'm at the midpoint of that line, and I just want to make another little line horizontally across the hinge, and that's going to allow me to define another little rectangle here from which we're going to be cutting material away from the hinge. So we've got that rectangle, and we're going to finish constraining it here with the perpendicular constraint. Let's constrain it to this line here. And I also want to make it the same length vertically as this other rectangle that I've already defined. So of course you could just dimension it here. say select the top and the bottom lines, and then you could just click on this dimension, and that's just this dimension means it's referencing this dimension. I've just gone and clicked this dimension here. It's going to say D7 because this 0.875 is D7. Hit enter. It's going to dimension it just like that. Now, alternatively, I'm going to delete that dimension, and I can use the equal constraint. So right here up at the top, and I'm going to make this line here equal with this line here. That is also going to fully constrain my sketch. Same effect, but you can use an equal constraint instead of just defining another dimension. So now we're ready to start cutting away some material. So we can hit Finish Sketch, and we're going to extrude this section here in this direction. So now you can kind of see our hinge starting to take shape. So for this scenario, it's going to be best to just use the through all constraint for this extrusion. Now you can extrude to faces and extrude different distances, but for this application, extrude all is going to work just fine. And of course, the operation here is cut. We're not trying to add material, we're trying to cut away material. So we're going to hit OK. That looks good. So now we've got a little hinge one starting to take shape. So we've also got some holes in the hinge that we're going to want to make. So to make those holes, we're going to make a sketch on this flat face here, looking at this front face of hinge 1, still in the hinge 1 component. And we're going to want to project in some geometry to reference our sketch off of. It's always going to be good practice. You typically are going to start a sketch by projecting in geometry from the bodies you've created. And so you're going to have this project window opened and pull in these sides for us to reference our sketch off of. So now that I've got those 3 sides selected, hit OK, and they show up as these purple projected lines. Now I'm going to make some points where I want these holes to be. Now again, we're just making these holes in this hinge 1 for the bolts to go through. So again, I've got these points that I'm making under Create, and I'm in this sketch. So I'm just going to put some points where I think I want the holes to be roughly. So now I'm going to dimension these points off of my projected geometry. So reasonable value for the distance in of these holes on this pin sheet, or on this hinge sheet, it's going to be about 0.5 inches. So we've got 0.5 inches there. We do not want to select the pin height parameter that we've defined, so we've got 0.5 there. Let's go ahead and make this dimension also 0.5. Again, we're just going to reference off of this 0.5 here by clicking on it. So if we were to change this 0.5, say we want it to be like 0.7, then both of these dimensions change. That's the power of referencing dimensions off of other dimensions. So back to 0.5. Now we're also going to want to constrain this little point here. Going to do the same thing, 0.5 referenced off of this dimension here. And from this point to this point, now you can dimension kind of diagonally here, or horizontally or vertically. What we want to do for this scenario is just dimension it vertically off of, again, this 0.5. So now that we've got those points constrained, we're going to do a pattern. So we've got 2 points here where we want the holes, and we also need 2 points down here where we want the holes. So of course you could draw those points in, and it'd be another kind of mirror of this sketch. We're going to do it a little bit easier way and just make a rectangular pattern. And we just want to pattern these 2 holes here. So it's a little bit, you have to play with it a little bit in order to kind of understand how the pattern works. But basically you have horizontal and you have vertical directions to make your patterns. So we're just going to make the quantity 1 for that horizontal direction, and then the quantity for this vertical direction here, we're just going to want 2 because we have 2 total sets of points, so 4 points in total. And then here, I'm just going to define that distance down, this distance here that I'm dragging right now, for where these points are going to be. So it works out to be -2 inches just because our pin height here is 3.5 total inches. Then you have 3.5 minus 0.5 for this, minus 0.5 on this lower portion, and then minus another 0.5 in between these 2 points. So maybe that's a little bit confusing, but I'll write it out here. So we've got pin height. Hold on, where did that go? So pin height minus 3 times 0.5. So you can see it's going the opposite direction that we want it to. So we're going to do minus pin height. And then we're also going to do plus 0.5 to make the sign work out, to make it go in the right direction. So that comes out to 2 inches in between this point and this point vertically. Sorry, 1.5 there, 2 inches from here to here. So this sketch is done. We're going to be ready to start making these holes. So I'm going to hit finish sketch. So to make holes, not sure if that's going to be okay. Anyways, to make holes, what we want to do is go under create, and we've got the hole function right here. So we just want to select these points where we want the holes to be, just like that. And so you can see that I've already got some parameters input for what these holes are going to look like. Depth of the holes, again, not super critical. We can just go ahead and make it the thickness of the material, which is 1/16. But in case we change the thickness, let's just make it a little bit thicker. Again, you could parameterize this so it's a little bit more robust, but this is going to be fine for this application. And then let's just go ahead and hit OK on this, and we'll come back to revisit these holes after we've taken a look at the screws that we're making these holes for. So I'm just going to pull up the file for these screws here. So these are just some standard steel screws for construction in wood. So looking at this drawing, the major diameter of these bolts, which is going to be how we reference the clearance diameter for these holes, looks like it's about 0.138 inches. So that's kind of the very minimum outer diameter that we want to make these holes. And to make it clearance so that it's just a slide fit, maybe we want to make it like 0.145 or something like that. So we go into this hole here, and so as I was saying, this dimension right here for the diameter of this hole, let's do 0.145. So we have a good fit for these bolts. 118 is going to be standard for most drills, and obviously you have to drill holes. And this 82 degrees is also going to be pretty standard. We're going to leave that alone because that is actually the angle of these bolts. You can see right here, 82 degrees. And the top portion of these bolts, this outer diameter at the head, 0.3. Let's take a look at the drawing. Looks like we've got this 0.279. So 0.3 is going to give us a nice countersink, so these bolts sit just a little bit inset from the face of this hinge. So we'll keep 0.3 where it is. So lastly, we're going to select countersink for the hole type. That means that instead of being like a flat hole like this here, we're actually going to be countersinking the head into this hinge. Just a simple hole, and it's going to be angled at the bottom, although obviously there's no bottom here, so it doesn't really matter which one you select here. So that's fine. We're going to hit OK, and we've got our holes. So now we've basically just created everything we need for one hinge, and we're going to want to add in another hinge and the screws and the pin. So let's go ahead and right-click on this hinge 1 component and just hit copy. And then let's activate this hinge 2 component, in which there's nothing here in the timeline. We haven't done anything in hinge 2. And we're just going to hit paste. So now you can see as it pops up in the timeline, we've got this whole hinge 2 here in the hinge 2 component. So I'm just going to drag this hinge out just a little bit so we can see that there are in fact 2 different hinges. And just to make it easier, let's just rotate this hinge around 180 degrees. And you can start to see this little assembly taking place. We've got 2 hinges that are going to fit together here. So now let's go ahead and work on this original hinge just real quick. Realize I missed just a couple little steps. So I'm going to go ahead and roll the timeline back so that the hinge 2 hasn't been created. And you just want to make a little fillet here at the top and bottom of this hinge. Just reasonable because it's not going to be a sharp corner on the actual hinge. So a reasonable value, say like 0.5. Obviously, if we had a hinge to measure, we could make that more exact. So now that we've got that fillet, let's go ahead and roll this timeline forward in Hinge 2. So we've got this move copy here, which is this little feature in the timeline. And you can see we've copied over this whole hinge with these little fillets. So now let's go ahead and bring in the pin and the bolts that we're going to need in this assembly also before we start joining them together. So click on the pin component. You can see that nothing's in the timeline, which is good. We haven't done anything in the hinge component. And let's go ahead and go to the pin. And again, this part number that I mentioned right here, let's just copy that. And Fusion has a nice feature where you can just import McMaster car components. So if we just hit Insert McMaster car component, that's just going to bring up the McMaster car website within a Fusion window. So we just want to Control V, paste that part number into the McMaster car interface, and we can see it's going to pull up the dowel pin for us. So if we scroll down just a little bit, we can see the part number here. It's highlighted, and we'll click on product detail. Now this product in particular, if you scroll all the way down, has this option to import a CAD file. Most McMaster components do have this option. So we'll just hit 3D step, which is a good file type that Fusion likes to accept, and we're going to hit save. So once it loads, it's just going to pull that pin right into our assembly, and notice we are activated within this pin 1 component, so it's just going to set this component with this part number of the pin within this pin 1 component. So that's exactly where we want it. We're going to hit OK. So now we're going to start joining them together. So if you look in this Assemble tab right here in the top ribbon, we got Joint. So this is going to let us start joining this pin with these 2 hinges. So we're just going to click. We've got 2 different selection boxes here. For the component 1, the component that's going to be moved, we're just going to click this outer face right here, and you can see it's snapped to the center. And then the component that's going to move 2 is this little component 2 selection box. And we just want it to be right here at the center of this hinge. So now you can see it's close, but it's flipped on the wrong axis. So we just want to hit this little flip joint origin, and that's going to put it in the correct orientation. So we're going to hit this motion tab here, and you can see there's many different types of joints that are going to constrain different types of motion. So if it's rigid, you can see it vibrating. They just don't move relative to one another. That's not exactly what we want, because we want the hinge to be able to swing open. So Revolute is just going to allow you to rotate about an axis, and you can select what axis that is here. Quick overview, you can just see slider, cylindrical, pin slot, planar, which isn't very commonly used, and ball. These are all pretty useful joints. Once you kind of get the hang of what they're for, I definitely recommend practicing with a couple different ones. So just like slider, for example, you can see it's sliding along an axis. Go back to Revolute, you can see it's rotating about an axis. They just do kind of different motion constraints like that. So let's just go ahead and hit OK on this joint, and that looks good. Let's go ahead and pull the other hinge, hinge 2, onto this pin here. Now if we just hit cancel real quick, let's notice that we are still in the pin 1 component, but it's creating these joints in the hinge assembly. That's what we want. So you kind of generally create joints in the assembly, and then have the individual rigid bodies in the individual components. And it's just kind of snapped this Revolute joint up into the main joint parent, because there weren't 2 components in hinge 1. There was only this one McMaster component that we inserted. So if we're activated in the hinge 1 assembly, just go ahead and do the same thing with the second Revolute joint that we needed. So actually first, we're going to select, actually no, that was right. We're going to select the component first that needs to be moved, and second, the component that it is moving to, so the component that's not moving. So select it like that, and you can see we've got a nice Revolute joint that can move 360 degrees around this pin. So we're going to go ahead and hit OK. And the last joint that we're going to create is a dependency between the 2 hinges. So we've constrained the 2 hinges to the pin, but we haven't constrained the 2 hinges relative to one another. So let's go ahead and do that. Let's just select this face on the hinge 1 component, you can see. And let's just select this other face on the hinge 2 component. So we're just joining 2 hinges together. Looks good. So now that defines a dependency between the 2 joints, and it's not just defined between the pin. So that's 3 revolute joints in total. We'll go ahead and hit OK. So now what we're going to want to do is import the screws to put inside of this assembly. Now you can see that if I were to drag this assembly, it all drags at once. And what we want to be able to do is open up this hinge and close it without the whole thing moving around when we drag it. So let's just hit revert on this little position ribbon that pops up when we drag. That'll pop it back to the original position. And what we want to do, let's just go ahead and roll back before we made these joints. Just make things a little bit easier. And we want to go into the hinge 1 component right here. Right click on it and hit ground. Now that's going to mean that hinge 1 doesn't move. So we can try to drag it, doesn't move, it's grounded. So you can also see beside the hinge 1 component, you see this little pin that also shows you that it's grounded. So let's go ahead and back up into the hinge assembly. We can roll these joints forward in the timeline. And now we can see that we can open and close this hinge without the entire assembly moving around because we've grounded hinge 1. So we're going to hit revert. And what we'd like to do is kind of have this hinge open just a little bit so that we can actually see the inside of it and get a better sense of what it looks like. So what we're going to do in order to make that kind of statically appear correctly, let's just go into this last joint that we made and hit edit joint, and we can define an angle that this joint is going to be at, just statically. So you can see 90 is turning the hinge the incorrect direction. That's just going to be a sign irregularity. So now if we just look back at negative 90, which I've input right in this angle tab here, we can see that this pin, this hinge looks pretty good. So let's click OK, and that's just going to pop it to this negative 90 position that we're going to be operating at. Now another way to do that, kind of a different way, is to go into edit joint limits, and you can set like a minimum and maximum operating point for this hinge in terms of the angle that it can swing through. And then you can also define a rest position. Right now our rest is basically negative 90, but we've defined that in the actual Revolute 3 joint and not in this joint limit tab. But just know that this exists, and I recommend that you play around with, say, setting a maximum hinge angle and a minimum hinge angle, just so you get a sense of a different way to kind of drive joints. And then the last thing you can do in this tab is just kind of show the animation for how the joint is going to behave. So we'll hit OK on that without having made any changes. So now we're going to go ahead and add these bolts in. So again, we're going to pull up the bolts, and you can just type in this McMaster car number right here. Inside of Fusion, click Insert, Insert McMaster car component, and we're just going to paste that in for the bolts. And you can see the bolts have popped up. We'll click on Product Detail, scroll all the way down. 3D step file is the file type that we want. Click on Save, and it'll go ahead and pull these bolts in for us. So we'll hit OK. Now you'll notice what we've done is we don't have this bolt here that we just imported inside of the bolts component. The ideal way to do it would have been to select the bolts component initially and then just import just how we did the McMaster car component, and it'd be underneath of this bolt component. But since we haven't done that, you could either just delete it and do it how I just said within this component, or we can take this component and just drag it into the bolts component. So that's just going to move it up under the bolts parent component, and we can see that feature of dragging the component up here in the timeline here. So that's going to be fine for what we want to do. So let's just click on joint, and we're going to want a rigid joint in between the bolt and, or screw rather, and the hinge. So we just select rigid here under motion. That's going to allow two components to not move relative to one another. And we want to select the component that's going to be moving first. So we want to move this bolt here. So we click on this top bolt face here. You can see that we've snapped to the center of this bolt. And we want to make that rigid with one of these bolt holes here at this top face. So that's a good look. That's what we're looking for in terms of how the bolt is going to go into the hinge. So we'll go ahead and hit OK. And now you can see if we try to drag this bolt around, it doesn't move because it's rigid with this grounded hinge 1 component. So we want 4 bolts, or maybe even 8, in order to fully finish up this model here. So we could just insert another MasterCard component and just do that 8 times to get 8 bolts. Or we could also just go into this bolt component here and right click on the actual bolt that we've imported. And let's go ahead and hit copy and then right click on bolts and hit paste. And that's just going to pull another bolt component in here. And let's just pull it off to the side so that we can see it independently of the other bolt. So let's just go ahead and join that bolt here by selecting this very top face of the bolt with the face of the hinge. And that's going to go ahead and just pull it over to be rigid with hinge 1. And you can see we have this rigid constraint on this joint. So let's hit OK. And if we wanted to add all 8 bolts in, you can just continue that process to go ahead and add 6 more bolts just by copying and pasting them into this bolts parent component, just like I've done here. So now what we want to do is let's look at an animation of this model. So we've got it set up pretty well, but what does it actually look like when it starts to move? So let's go ahead and go back into our Hinge Assembly component and right click on the Revolute 3, and you can see some different options here for this joint. We can animate the joint or we can animate the model. So let's go ahead and click on Animate Model. And that's going to show the this Revolute joint in the context of this assembly and the motion that it's constraining and the motion that it allows. So that's a nice animation. We'll hit Control Z to hop out of that animation. I'll go ahead and talk about this edit joint limits here. If you just hover over Revolute 3, hit edit joint limits. Let's go ahead and cover this maximum and minimum position. So right now we're operating at a rest of 0 degrees, which is defined here at this 90 degree angle between the 2 hinges. So let's keep the rest at 0 degrees. It's a good spot to stay at. And the maximum, let's just make it say 80 degrees from this point here, this rest point. And the minimum, let's do say negative 80 degrees from the rest point. So you can see, if we were to animate this model, now we've constrained this hinge to just move from negative 80 to positive 80 degrees, and it's not going to overextend itself in the animation. So if we hit stop, it'll stop the animation, and we'll click on OK. So it's going to snap back to that 90 degree rest position, and if we drag this joint around, you can see it stops at those negative 80 and positive 80 degree points that we've just defined. So that's pretty helpful. And then if we let go, it's going to snap back to that 0 degree rest at that 90 degree angle that we've defined between the 2 joints. So that's how you create an assembly in Fusion, and hopefully that was a good overview of a couple of the joints and kind of defining components relative to one another. A good exercise to kind of go through at home in the future would be to say insert this hinge into a larger assembly of, say, a door that this hinge would bolt onto. So we can just kind of go through that real quick. I can kind of give you an overview of what that would look like if you want to go ahead and tackle that problem. So we'll go ahead into the main hinge recording component, and let's make a new component called door. And we'll click OK, and we can see this door component has popped up separate of the hinge assembly. So the hinge assembly is not, it's transparent right now, and so we're not in that hinge assembly, we're in the door, which has nothing created in the timeline because we just made it. Let's make a new sketch in the door, and let's actually hide the hinge assembly so it doesn't get in the way. And so we'll just sketch on this top plane here, and let's just make a rectangular door. This is just going to be the top-down cross-section of the door, referenced off of the origin in this model. And we'll just place a rectangle right about here for the door. Now let's say our door is 4 feet wide, so we just type in 4 foot there. It's going to pop out to 48 inches, and maybe it's a 1.5 inch thick door. So that looks pretty reasonable. Let's go ahead and just extrude this door upwards. Say it's a 7.5 foot door. And that looks good. It's a new body under this door component. So that's not too bad. Make it a little bit more realistic. Let's just right click on this door component and click on appearance. And we should be able to find some wood in this Fusion library of materials. Just click on cherry and pull it over to the door. And we can see this turns into a cherry door. So let's hit close, and now we've defined the physical appearance of this door. So let's create a bolt pattern for our hinge to bolt onto. And now that I think about it, let's make this door just a little bit thicker. Maybe it's not super realistic, but it's a 2.5 inch thick door. So we're still in the door component. We're going to create a little sketch here on the side of this door. Let's project this rectangular section of the door so that we can reference our geometry of the sketch off of that projection. And let's just go down here and start sketching some holes for this hinge to bolt into. So just roughly, let's go ahead and put some holes here. And we're going to want to screw into these holes, so they're going to be a little bit smaller than the major diameter of that bolt, which, if we look back at the bolt, happened to be this 0.138. So maybe the bolt holes are like a 0.11 or something like that, say like 0.09. So some pretty small holes here. Let's just make it like a 0.11. And let's use the equal constraint to make these two holes equal. So now let's just define these holes relative to the bottom of the door. Again, if we had like a door that we were designing for, we could actually make this more realistic. But let's say it's 8 inches from the bottom of this door. And then let's go ahead and pull this hole up a little bit, and it's going to be 1/2 inch away from the other hole vertically, because that's how we made the hinge. And this other hole here, or this hole on the left, is going to need some horizontal definition from the hole on the right. And let's say 1.5. I'll have to go back and measure the hinge to see what it actually is. So we still haven't defined these holes horizontally yet. We haven't constrained them. So let's just go ahead and create a line starting from this left hole over to the right, and it's got this horizontal constraint on it. That's good. Go ahead and make it horizontal, and hit X on your keyboard to just make it a little construction line. And let's do a horizontal vertical from this point to this point at the center of the circle here. And finally, let's just make a point here at the center of this line, and it's not to the midpoint, which is good. Now let's do one more point down here on this projected line at the bottom of the door, and we're going to go ahead and make those 2 points horizontal vertical. So horizontally or vertically from this point here to a vertical constraint here at this point. And now you can see we've fully defined these circles, and of course we can pattern them just like we did on the hinge. Let's just pattern vertically here, and of course you could parameterize this, but I think it's 2 inches. I believe we just make that. Yeah, that'll work just fine. And let's edit that pattern because it doesn't look like I've grabbed that last hole there. So of course I clicked on that point rather than the actual circle. So now if I click on the actual circle, it's going to pull the circle up in that pattern. So we've got those circles defined there. We're going to hit Finish Sketch, and we're just going to extrude them into the door. A reasonable depth that you drill a hole, say like -3 inches. Now I've got some holes in this door, and we'll go ahead and check these holes relative to the hinge that we've created. So if you just right click on Hinge Assembly and click on Isolate, that's going to hide everything other than the hinge assembly. So let's just check the distance between those two holes, because we're going to need that to define the holes on the door. So if we look at the X and Y distance, it looks like it's 0.81. You can see that in the delta X here. So we need a 0.81 spacing between the two holes horizontally, and it looks like we're going to need a 2-inch spacing between the holes vertically. So let's just go back into the door component, isolate, and go back into this hole sketch that we have. And I think I said it was 0.81. Looks good. And I believe this to this is 2, which is good. So finish sketch. It's going to change our holes there. And just to finish up, let's go into Hinge Recording, the main component, on Isolate All, so now we can see both of these major parent components. And we'll go ahead and make a joint between the hinge and the door. So we want the hinge to move. We don't want the door to move. So let's go ahead and hide the door and select a face on the hinge. Now you can see, because of how we set our components up, we can actually only select this hinge 2 component here, which is fine. Let's just go ahead and select that hinge 2, the hole where we want to join them, and we'll bring the visibility back on the door and just select that hole right there. So you can see it's flipped. We want to flip it like that with this little flip button, and let's bring it down so that it matches up with these holes at 180 degrees. And if we hit OK on that, it looks like it has snapped to the right position that we're looking for. So now we've got a hinge on a door, and if we try to move this around, it does in fact pivot with this grounded hinge 1, pivoting on the hinge 2 around this pin, and obviously moving the door. And the door is just going to snap back to that point that we defined in the joint to be the rest position of that hinge. To make this look a little bit better, you can just hide the joint visibility, and now you can see that we've got the joint and the door. So if you have any questions about how I did all of this, and want some guidance, or just have some questions about CAD in general, definitely stop by my office hours that I'll announce for next week, and I can definitely walk you through some things and show you more if you want to keep doing some more CAD work. Thanks for coming to this CAD session, and I hope you learned something. Have a good one.